In this video, we're going to be taking an in-depth look at what is required for our TP controller class. So for starters, let's just jot down some notes to cover the basic functionality that we're going to need. So here we are with TP controller. Now we already established some of the functionality that we're going to need in the previous video, but now we're going to go back over that and add a few more specific functionality aspects that we really didn't need to cover at such a high level. So for starters, let's talk about primary functionality. And then secondary functionality. So, where do we begin with primary functionality?
Well, its very first function, or its primary function, if you would, is to actually take the player input and convert it into a 3D vector, or a vector 3.
So, well, let's separate that out. So, we're going to start off just by taking in player inputs, and these are going to be axial inputs from a game control device, such as a joystick, gamepad, the keyboard perhaps. It's not dealing with the mouse, though. The mouse is something we're going to be handling separately, and that's what's going to be driving our camera. So if you're thinking this has to do with mouse inputs, in our case it doesn't.
Right.
So it's going to take in these player inputs, and from these it's going to create a vector, which we're simply going to call move vector. Now, are there any other primary aspects of the primary functionality aspects that we need to worry about?
Right. After it's created the move vector, it's going to force the TP motor to update.
Now, that's something we didn't actually discuss at the high-level overview. The TP controller is going to be responsible for forcing the update of the TP motor class.
Right. Instead of letting TP motor do the update on its own, we're going to use the TP controller to force when that's going to happen. It's going to actually kind of control the synchronization between the two, because we only want the update to happen after we've created that vector.
Right.
If we allowed the TP motor to handle it on its own, it may or may not have the information it needs. So we don't want to allow that to happen.
Gotcha. So up to this point, let's see, if I was just going to start, I don't know, trying to really drive this home. We've got our inputs. I don't know, I want to put a start and select button there. I guess you could do a cable too. I mean, it should be a wireless controller, but I don't know, man.
Well, it is 2010. So.
I got to throw back to the old classic cable controllers. So we've got our inputs from the player, and these are going to be processed into a vector. And for the time being, I'm just going to draw out a two-dimensional plane. And I'm not going to worry about whether one dimension is X and one dimension is Y. We're simply going to have... Actually, you know what? I'm not going to draw it flat like that for now. I don't want this to be any more confusing. So let's just say this is the plane in which we're going to do it, and we have a horizontal axis. And we have a vertical axis. And say, like, if we're pushing up on the D-pad, we are plotting a point somewhere here on the graph. And if we're also pushing, say, to the right on the D-pad, we're plotting a point somewhere over here. And that is going to create a vector for us. And so that's exactly what we're doing up to this point. And then once we're done with that, we're going to say, we're going to go call on TP motor. Not Matro. Wow, that was great. TP motor, and kind of just yell at him real quick. So he's yelling and saying, hey, you see this thing? I want you to process it. So it's kind of like we calculate our vector, and then we deliver that over to our TP motor.
Right, and then we tell TP motor to go ahead and update the motor, and then it will take that information, do all the processing calculations it needs to.
We say, TP motor, go!
Yeah.
And that's how we could define our primary functionality. in a more visual sense. Now, there's some other things, too, some secondary functionality inherent to TP Controller that we're going to need.
There's actually some housekeeping that TP Controller has to deal with.
Ooh, so let's put that in parentheses. I like that. Housekeeping. So what's the first secondary functionality?
Well, it needs to keep a couple of references to keep the communication flowing. And the very first reference that it needs to keep track of is the character controller. It needs a reference to that character controller component that we created on our character back a couple of videos when we actually created that really cool smiley, or they didn't even have a smile. So
well, you could just say the smile's implied. He's smiling on the inside.
Yeah, there it is.
He smiles with his eyes, really. But we need some sort of a reference to that character controller component, because we're going to be using that to help us determine if we're moving properly, like are we colliding with the ground, that sort of thing.
Right. He has some built-in functionality that we need to get a hold of. Basically, he's the component that we need to talk to actually move our character. He's also responsible for, as you were saying, telling us whether or not he's on the ground or not. And to get access to that, we need a reference to him. And instead of having to create this reference in every single class, we're going to make a static reference in our TP controller, and we'll just access them via that mechanism.
Gotcha. All right, so now we've got our first reference being, okay, of course, a reference to the character controller component, but you said there were references plural. What's our other reference?
Well, our other reference is going to be an instance to himself. This class's instance that gets created when we drag this out onto the character. You'll find that all of our TP classes that we're creating are going to hold a static reference to themselves. They are mono behaviors, but I'm going to hold a reference to them so it's easy to access from other classes.
Okay, just a simple way to help them all talk to one another.
Right.
All right, so that's our first aspect of our secondary functionality. We establish these references and say, all right, you need to be able to talk to the character controller component. You also may need to be able to talk to yourself, or other people may need to talk to you, so let's slap a name badge on you.
Yep.
Now what?
Well, as we mentioned in our overview, is there's some camera functionality we have to make sure is in place.
And one of which was an initial check when the game begins to make sure we have a main camera.
Right.
So that will be one of the secondary functions. And we'll say this is the initial camera check. Now, is TP Controller actually going to perform any tasks based off what it finds?
Other than telling TP Camera to go create a camera, that's all it's going to do for the initial check. It's not even going to do it internally here. It's just going to tell the TP Camera class, hey, at this point in time, I want you to go make sure the camera's set up.
Okay.
And it just fires off that request, and then the TP Camera will deal with it when it sees fit. So when we get to the part of implementation, because we don't have a TP camera yet, we're not actually going to code this in straight off the bat. We'll come back and add it, but it is functionality that we will have to put into TP controller.
Okay.
Now, along with this, we have the regular check that's going to happen on every update cycle to make sure that the camera is still there.
Okay, so we could just say a continuous camera check as well.
Right. And this, while not required, is just a fail-safe. For some reason, something happens and the main camera gets destroyed. This will stop the whole controller process from taking place if a camera ceases to exist.
And keep us from getting any null reference errors.
Right. And one of the problems with 64-bit Unity at this point in time is it doesn't always gracefully handle null references, and because I develop on a 64-bit platform, I try to prevent null references from ever happening because they could potentially crash Unity completely.
Right, and without trying to jump too far ahead, really, it just boils down to saying all this stuff, all of our primary functionality, only do it if the camera still exists. I mean, it's not like a really involved thing. Okay, so that is a quick rundown of our primary and our secondary functionality, along with a really cool graphical walkthrough of everything that's going to be happening with our primary functionality. So now let's take this, and I'm just going to hide it, and let's create a new layer in which to draw on. So now what I want to do is let's go into the specifics of what we're going to be doing to make all this happen. What do we need in terms of our actual programming code?
All right. Well, we're going to need a couple of fields.
Okay.
And we're going to create 2 static fields.
And these will be, okay, so I could just say these will be static fields.
Yes.
Now, 2 of them, what's the first one going to be?
Well, our first one is going to be a character controller. It's actually of type character controller, and we're going to call it character controller. This is what is going to hold the reference to the character controller component that we added to our character.
Okay, which we kind of discussed just a moment ago. And really, the idea is just to make sure that we can easily address that character controller should we need to. What's the other field we're going to create?
Well, the other field is called instance, and it's of type TP controller. Basically, this is a reference to a TP controller class. And the one that we're going to hold the reference to is actually the one that's being created when we start the game.
So technically, this is a reference to this instance of this class that we're working on.
Right. When we create this class and we actually wire him up into the character, because this class extends mono behavior, we're actually going to take it and we're going to drag and drop it onto our character, which means the moment we start playing the game, the Unity is going to create an instance of this class. Mm-hmm. We're going to hold a reference to the instance that Unity creates in the static field called instance.
Yeah.
And it just makes it an easy way for me to reference this specific copy that Unity has created.
That's right. And the key here is just to make these objects more accessible.
Right. What will happen as we create more of these TP classes, I will need to be able to reference the controller, or I may need to reference the motor or the camera for that matter.
Right.
And this just makes it very quick for me to just type in TP controller.instance, and then I have access to all the functionality that we've exposed as public inside of classes.
Dot some functionality.
Yes.
So yeah, that's really all we're going to be setting up here in terms of our fields, is just giving ourselves the ability to, at any point amongst any of our classes, say tpcontroller.instance whatever some aspect of functionality we've coded in so that we can access all that stuff easily from any point in our code.
Right, kind of a little bit of foreshadowing. One of the things we'll be doing at some point in time is say jump.
Okay.
And this would be, I could tell tpcontroller.instance.jump, and this would tell the controller, I want to jump. Right. And then that method would handle everything it needed to do the jump.
Yeah, in the end, it's all about easy communication.
And this isn't the only way things can be done. There are lots of ways that you could do this on your own. What I'm trying to do is bridge the gap from our simple game project that we did in another series several months back, and where we're going with our advanced simple game and into the MMO projects that will be coming up.
Well, that's really true of any programming solution. It's always one way to go about it. Usually there's many, many, many ways to handle just about any given problem, especially in programming. So these are the fields we're going to need, but I imagine fields aren't everything. That's not all we're going to need to make this happen.
No, we're actually going to need some methods.
Okay. So let's take a look at some methods. Now I'm going to go ahead and probably start writing just a little bit smaller, because I imagine I've got more to say here than I did previously.
Right. Well, TP controller extends a mono behavior.
Okay.
A mono behavior has base functionality in it, and it has a couple of methods that you can override.
Okay.
And what we're going to be overriding is our very first method, which is awake. Now, this method is something that, being a mono behavior, when Unity starts running, this will be the very first method that gets called after it creates this an instance of this class. So this is what takes place first, and this is where we want to do all of our initial setup for getting our class ready to run.
So we'll say right after. Oh, you got
sorry.
the mouse.
Oh, sorry.
Let me finish writing.
I bumped the mouse. My bad.
All right, and there you go. Now it's all yours.
All right. So we've got a couple of initial things that we need to do inside of Awake.
Mm-hmm.
The very first thing is assigning our references.
So we'll go ahead and jot that down. That'll be his first bit of functionality, and those will be those static fields that we set up.
The character controller and instance. So basically what we're going to do in Awake is we're going to go find the character controller component, and we're going to assign a reference, or its reference to character controller.
Gotcha.
Then we're going to tell instance to be equal to this, which is basically assigning it the reference to itself.
Okay. And so that's pretty simple functionality. That's just making sure these fields are actually doing something.
Right. It's going to have a little another method, or not so much a method, but it's going to be responsible for doing one other thing, and that's the initial setup of the camera. It's going to have to call a method inside of TP Camera to set up the camera, get ready to use.
And that's something we'll actually talk about later once we have TP Camera in place.
Right. We can't add it now because that method and that class don't exist. So it would just cause an error if we added it now. But after we create our TP Camera, we'll come back and add this functionality into the Awake method.
Gotcha. So two things. It slaps the name badges onto itself and onto the character controller class so that we can call those much more easily. And it's also going to look back over its shoulder and see if there's a camera.
Right.
So what else have we got?
Well, the next method is another built-in method that we get from extending mono behavior, and that is update.
Okay. I'm still drawing here. So this is our guy. He's asking to see if there's a camera.
Ah.
I don't know. I like having a little graphic. All right, so next we've got our update.
Right. Now, update is going to be called every frame.
Yeah, and we've already made use of that in the past. Called every frame.
Right. So the very first thing that it's going to be responsible for doing is checking that their main cameras still exist.
Verify main camera existence.
Right. If it does not find a main camera, it's going to exit. It's not going to go any further.
So, and this just comes back to he's just still, hey, looking for that camera.
Yeah.
So we're doing that once during Awake, and that's something we're going to handle a little bit later. That's how we're going to be able to tell TP Camera, hey, you know, is there a camera? If not, make one. If there is, let's take control of it. And then throughout gameplay, we're going to be verifying the main camera's existence. And if it doesn't exist, we're just not going to do anything.
Right. We're going to actually exit out of it, which means your game will cease to take character or player input. We're not going to end the game or crash out the game. We're just not going to process any more input.
Okay.
And that'll allow you to deal with it however you see fit.
Okay. So it basically, if this doesn't exist, then we'll stop taking input. All right, cool. Is there anything else we're going to be doing in update?
Well, after we verify that the camera still exists, if it does exist, we're going to go look for player input.
Okay.
So we're going to call a method called getLocomotionInput.
So instead of discussing what that does here, we'll just say, in this case, call on getLocomotionInput. And I'll probably actually turn the page to get to that. And what
Right, we're going to cover that functionality after we finish discussing what update does.
All right. So we're going to call on getLocomotionInput, which we can just say in general, it does exactly what the name suggests. It's going to take in those inputs from the player.
And it's going to build the move vector.
Right. And we'll talk more about that here in just a moment when we go into that method in particular.
Right. So once we get returned back from the getLocomotionInput, we're going to have our new move vector built. So what we're going to do at that point is we're going to tell the TP motor to go ahead and update itself.
Okay.
And because we want to ensure that our move vector has been built before TP motor updates itself, this is why we're forcing the update from this part. We now know that we've looked for player input. We've built that move vector. Now it's okay for the TP motor to update.
That's right. it's important to point out that this is critical. I don't know what I'm trying to before this.
Yep.
So we've got to make sure that the get locomotion input is done, because that's where we're going to have our vector. And then once we have our vector, then we can call on TP motor and say, all right, we've got our vector, go, do your thing, work your magic. So that's our awake and update methods. What other methods are we going to have?
Well, the last method that we're going to implement in TP controller is the get locomotion input method itself.
And this guy's actually going to get his own page because he's important.
Yep.
The get locomotion input method. So just put a little open and close parentheses.
Now, the very first thing that he's going to do is he's going to create a var to hold our dead space. Now, what dead space is a mechanism that we can desensitize our vertical and horizontal axes by. If you remember the old days of analog controllers, sometimes they would have drift, or where they wouldn't exactly zero out to 0.
Yeah.
And what we don't want to happen is, for some reason, if somebody's using a joystick or a gamepad, or if there's some errors where the vertical and horizontal axes are not returning exactly 0, we don't want our character to kind of be drifting around the world.
Right. I mean, and if you picture your horizontal and your vertical input on whatever device you might have as being a two-dimensional graph, like so. So you've got your horizontal axis and you've got your vertical axis, where generally your horizontal is going to be X and your vertical is going to be Y, at least in terms of the controller itself. But I don't want to get into axis names just yet. That'll be important a little bit later.
Right.
The dead space would be an area inside. So if the center here was going to be 0, we'd have a little bit of an area defined somewhere here in the middle, where we're basically saying the controller hasn't moved far enough to consider this to be an input. And that's all we're doing here. In fact, what I'm going to do, sorry, I'm being really nitpicky on myself. I'm just going to make sure that's a little more even and not quite so lopsided. But the idea is just saying, all right, the motion that we detected in the controller is so negligible, so small, that we don't want to send this out to the game and say, all right, they're trying to move this far, because you'd end up with a character that, you know, if things weren't calibrated just right, your character would start to kind of gradually drift off to the left or the right or forward or back.
Right. And when our character is idle or stationary, we really want them to be stationary and not just sliding around.
That's right. So we have our dead space. Right. Now, what else?
Well, the next thing that we need to do is we need to zero out our move vector. So at the beginning of every update, we want to start with a move vector that is 0.
0 out, and I'll just put in parentheses here, reset the move vector.
Right. We actually want to create our move vector every update.
From 0.
Right.
So start it over from scratch, because if you don't, then your motion is going to start being additive. You'll take the motion of the previous frame or previous calculation, and you'll add that to this one, and then you'll add that to this one, and then you'll just steadily keep going faster and faster and faster.
Right.
Or, well, you'll end up with a vector that gets longer and longer and longer anyway, so we don't want to do that.
Unless for some reason you've magically figured out to go for every right, you've gone left exactly once. That'd be kind of hard to do.
All right, so no, we're not going to handle all that. We're just going to say 0 out the move vector before we do anything.
Right. Now, the third part is going to happen in 2 stages. And this is the part where we actually are going to build our new move vector.
2 stages. So what I'll do here, let's do it like
we
this.
have 3A.
Yeah, let's say we'll have step 3A. And what's the first step?
Okay. 3A is going to look at our vertical axis and make sure that we're outside of our dead space.
Okay.
If we are outside of our dead space, it's going to assign whatever the motion in vertical to our z-axis of the vector that we're going to build, or to our move vector z.
And then we'll just say, if so, apply the vertical axis motion or vertical axis location. It's all dependent on how you look at it.
Right.
The vertical axis input, let's just keep it simple.
Right. What's going to happen is it's going to check the vertical axis. That is going to return a number somewhere between -1 and 1.
Mm-hmm.
So as long as that number is greater than our dead space in both positive and negative, we'll take that number and we'll apply it to the z of our move vector.
Okay, vertical, yeah. Make sure I write the correct axis. So this will be to the z-axis
of move vector.
And I'll talk briefly about how we choose z-axis here in just a moment. Actually, let's go ahead and do that now.
Okay.
So you see how this the dead space thing works on our graph. The thing is, I've got to draw this a little bit smaller. The inputs for our controller, the inputs from our whatever control device we have, are really just two-dimensional, having just a horizontal and a vertical axis. So if we're checking the vertical axis, and let's say we've got a full 100% of force, and we just consider that to be 1 in vertical, you could say we're plotting that up here on our two-dimensional grid. However, we have got to convert that to lateral 3D motion. And by lateral, I mean motion that's only going to go forward, backward, left, and right. Which means we have got to get it into 3D space instead of just 2D, where 2D just has vertical and horizontal. We've got to have all 3 directions. So we would have our z-axis, which points forward and back. We would have our x-axis, which points left and right. And, of course, we have our y-axis, which points up and down. We're not interested in the y-axis.
Right.
That's all handled completely separately. We're not dealing with that at all right now. All we're worried about is our lateral motion in z and x. And if we're considering the vertical motion of our control device, the up and down of your joystick, to be forward motion, then we have to take that vertical motion and assign that to the z-axis.
Right. If you remember when we're discussing creating your character, that the forward axis of your character is the positive z direction.
Mm-hmm.
So by vertical translating to forward and backwards motion, a positive vertical motion is going to be positive z direction, and a negative vertical is going to be a negative z. So that is why we're taking our vertical axis and converting that to the z-axis of our move vector.
So at this point, we would have plotted a point here on our 3-dimensional grid.
Right.
All right, so at that point, we've plotted the z-axis of our move vector. Now what?
Well, now for step 3b. We're going to do the exact same thing for our horizontal motion.
So I don't want to write all that again. So everything from 3a, but we're going to be
applying it to the x-axis.
Yeah, applying the horizontal motion. The horizontal input to the x-axis. And again, now we see exactly why that's got to be. If this is our x-axis, the horizontal motion, and let's just say we had a 1 for our horizontal as well. So in this case, it'd be like holding the joystick up and to the right as far as it'll possibly go. We're plotting that like so. That will have to be fed into the x-axis. So now there's where we're plotting in our 2D controller space, the input space is what I'll just call that tentatively for now.
Right.
And here's where it would plot in a 3D vector.
Right, and if we're looking at the vector and writing that out, it would actually be in parentheses, 1, comma, 0, comma, 1.
That's right, and all we've assigned at this point is just z and x. So in this case, yeah, it would be 1, comma, 0, because we're not touching y, and then 1.
Right.
For all 3 of our...
And that would be our move vector that we are going to tell our motor to deal with.
Right, and if we were to plot this out, so we'd be following along this line here and along this line here from 0, the vector would do something like that, and then here in 3D space, it would do something like this. So we have a two-dimensional vector literally coming out of the controller, and then here inside of getLocomotionInput, we're converting that into a 3D vector that's just not touching the Y vertical axis, the axis that goes up and down in the world.
Right.
So is that everything that getLocomotion needs to do?
Mm-hmm. For this one, I think in the next video we'll actually skeleton in the TP controller. We're not going to code in all the functionality yet, but we're going to get it ready to go.
Okay, so before we run away, I do want to just make sure we review everything, because we've gone through like 3 separate boards of information here. Actually, 4 boards. So starting at the very beginning, all we've done is we've covered the primary functionality of what TP controller needs to do, listed here and then kind of drawn out here in sort of a more graphic format. We've got we need to take in our player inputs. What is our player pressing on the keyboard? What are they hitting on the D-pad, etc., and so forth. We're going to use those to create a vector, and you've now seen how that works. How we're going to take the controller space, the horizontal and vertical axes defined by whatever the inputs happen to be. We're going to convert that into a 3D vector so that that can later on be applied to world space motion through a little bit more calculation. Because right now, really, if you think about it, we'd only be moving in world Z and world X. We can only move in these 2 directions, and they have nothing to do with where the player's looking. We'll get to that. Right now, it's just simply take this 2-dimensional vector, make it a 3D vector. We're going to force the update of the TP motor class. Once we have this 3D vector, we need to say, hey, TP motor, we're done doing our part. You're going to have to perform some calculations at this point. And we'll talk about what TP motor is going to do, of course, when we go to theorize how that class is going to work. Secondary functionality, stuff that we don't necessarily need to draw out. We're going to establish some references to the character controller component that is assigned to this character. We're going to need to access information from that component at all times to make sure that we're colliding with the ground, that everything's behaving properly in terms of how Unity expects the character to move around. We're also going to create a reference to this instance of the TP controller class, so that all we have to do if we need to talk to this class is just say tpcontroller.somestuff. We're going to run an initial check for the camera, and then really we're just performing the check here and calling on TP camera to respond accordingly. And we'll talk about TP camera's functionality and its response to that check later on once we get to that class. Also, throughout playback, we're going to be doing a continuous camera check and using the results of that to determine whether or not TP controller is actually doing anything.
Right.
Now, that's the first bit of functionality that we kind of marched through. Now, to do this, we need a couple of fields. The first is the character controller field, which will just be a reference to that character component. Talked about that just a second ago. Another will just be a reference to this instance of the TP controller. And again, the idea here is to just make these objects more easily accessible across all of our classes. Now, moving on from here, our next bit was just looking at our methods. So the first method that we discussed was awake. Now, this is already built into MonoBehavior, and this takes place first. This is right after all of our classes get instanced and the game is ready to go. This is the first thing that's going to be fired. Within this, we're going to assign the references to our static fields. So we'll get all those set up just like we discussed just a moment ago, and then we're going to perform that initial camera check first, and that's pretty much it. Next, we have our update class. Within update, we're going to be verifying the main camera's existence at all times. Basically, all we're going to be doing is saying, hey, all the stuff we need to do in update, we're only going to do if the camera exists. As soon as the camera no longer exists, just stop doing everything else. Now, what is that everything else? We're going to call on getLocomotionInput, which we'll talk about in just a moment, and we have to do that before we tell TP motor to update. We've got to calculate that vector so that that vector can then be passed off to motor, and motor can say like, oh, okay, here this is, and it'll process it on its own. We'll talk about what motor's going to do a little bit later in another video. Now, finally, we went into the specifics of the getLocomotionInput method. This is going to first create a variable that is going to hold a predetermined dead space, which this would be something you may need to configure or expose so that it is configurable for various projects. I mean, if you have an old school joystick, like a really old one that I still picture had like the great big red button on top, that might need a wide joystick because of calibration issues. Or, you could just have a very, very tight one if you want a very tight feeling control. If you've got like an Xbox 360 controller that you're using to control your game and you want just the tiniest amount of motion or pressure on that stick to be felt at the character level, you'd want a really small dead space. That's really all it boils down to. Now, if the input that is detected from the player is greater than or falls outside the realm of the dead space, then we've got to do some work. We're going to reset our previous move vector to 0, because we're going to be making this calculation from scratch, starting from 0 at the origin of our grid every single frame, so that we don't end up with an additive vector. Now, what are we doing to create this vector? First, we're going to at this point, we're going to verify that our vertical motion is outside the dead space. If it is, we'll apply the vertical input to the z-axis. Remember, z is forward. So if you move your joystick up, that is going to move the character forward. If we, and then the same thing for the horizontal axis, we're going to check and make sure that the horizontal motion is outside the dead space. If it is, we're going to apply that to a 3D x-axis. So if we move our joystick to the side, that is going to move the character left or right. All of that gets assigned to a 3D vector that is completely ignoring the y-axis. We're just assigning it to x and z only. So that's everything that we've discussed. That is all of our primary functionality. Hopefully at this point you now completely understand what we're going to be doing. In the next video, we're going to get the skeleton of the code in place so that we'll have basically just some empty methods. We'll get our fields established, and then from there we'll go on and worry about how we're going to code the rest of that in, although we're probably going to have to talk a little bit about TP motor before we go into coding this actual functionality.
Right, we're going to have TP motor in place before we can actually call some of the stuff that we need to get access to.
Right, and we'll talk about that and the reasons for that in upcoming videos. But that is going to wrap things up for this video. Thanks a lot.